Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to talk about how to find the arc length of a circle. So there's two things I want to say before we get into the questions. How do we find the arc length of a circle? So the first thing I want to say is imagine you just have a normal circle, and let's say we have a radius of, let's say 2. Basically, what I want you to realize for arc length is that it's just the distance on the outside of a circle. Now you'll notice in red, I did the entire circle, right? So the entire circle has an arc length that's the exact same thing as the circumference. In other words, the circumference is like the total circle arc length, and hopefully we know that the circumference equation is 2 pi r. So in this example, r is 2, so then the circumference is 4 pi. Now that's if it's the entire circle. That's not usually what we have. For most arc length problems, what we're really doing is you have a circle, okay, and you just want to find part of the arc length, let's say from here to here. And normally it's defined by some kind of central angle right here, like let's say 30 degrees. Well, the secret to finding this arc length is two things. Number one, you have to realize there's two ways you can represent arc length. One is a distance. We just talked about distance in the last thing I showed you. The other way you can say it is degrees. In other words, if that's 30-degree angle right there, I automatically know that this is 30 degrees right here if this is a central angle. A central angle just means that the angle is formed at the center of the circle. If it's not formed at the center of the circle, this strategy will not work. I'll cover how to do that in a separate video. But all of the problems we're looking at today assumes it's a central angle, which means you automatically know the arc length in degrees. But then the question is, well, sure, I have the arc length in degrees. How am I going to find the arc length as a number, a distance, like we just did with the circumference? Here is the equation. So it's going to be a proportion. If you don't know what a proportion is, just watch and learn. So first, put the degrees over 360 and set that equal to the arc length, which I'll just call L as a variable, divided by 2 pi r. Now here's why this makes sense. Basically your degrees in this example is 30 degrees. It's the proportion of the arc length that you have in degrees divided by 360. And the reason why it has to be 360 is because how many degrees are in a circle? 360. Okay, so that's why that makes sense. And then you set it equal to the arc length, which most of the time that's what you're solving for as a distance. And then you divide it by 2 pi r, which if you think of it, 2 pi r is the total arc length as a distance. So in other words, 360 degrees is the total in degrees, 2 pi r is the total as a distance. That's why this proportion works. So with that being said, let's go ahead and look at some examples and solve. So for the first one here, I'm going to have, let's say, a central angle right here of 12 degrees, and I know that the radius is going to be 5. And I would like to find the arc length. So here's what I'm going to do. First, I recognize that because this angle is 12 degrees, I automatically know that this arc length right here is 12 degrees. And so when I set up my proportion, degrees over 360 equals L over 2 pi r, I know it's going to be 12 over 360 is equal to L, which is what I'm solving for. It's the arc length, divided by 2 pi times r is 5. And now if I want to solve for L, it's the only thing left. I just have to cross multiply. So on the left, I have 12 times 2 times pi times 5, which I'll plug in a calculator. And then on the right, I have 360 L. And now I can just use algebra to solve. So for this one on the left side, I'm not going to plug in 3.14 for pi. I'm going to leave it as pi. And so in other words, I'm only doing 12 times 2 times 5 in my calculator, which is going to get me 120 pi. In other words, just keep the pi at the end. You don't have to multiply by 3.14. This is perfectly fine. And then on the right, I have 360 L. And if I want to solve for L, all I got to do is divide both sides by 360. That's going to give me 120 pi over 360 equals L. And 120 over 360, that's just 1/3. So it's 1/3 pi. That is my arc length. 1/3 pi. And there we go, that's the first one. Now let's go ahead and do another one. This one's going to be harder. So for this one, I'm going to draw a bigger circle because I need to show more stuff. Okay, I'm going to give you two angles here this time, here and here. I'm going to tell you this angle is 45 degrees, this angle is going to be 30 degrees, and the arc length I want to find is actually on the outside. In other words, I don't want the arc length on the two angles I gave you, I want to find it for the outside. So there's actually two ways you can solve this. I'm going to show you both ways. Probably the easiest way to solve it is to say, hey, you have what angle here? 30 plus 45, that's like a total of 75 degrees. Okay, well then what's the remaining angle right here? Well, that angle is just 360 minus 75 degrees, which is going to be 285 degrees. And now that's the angle I want, and that's the angle I'm going to plug into my equation. So remember, the equation is degrees, which we're saying is 285, divided by the total, 360, is equal to L, the arc length, divided by 2 pi r, and I forget to give you a radius. So to make the problem extra challenging, I'm not going to give you a radius, I'm going to give you the diameter. And let's say the diameter is 24. Now really that's not too much harder, because we know radius is just equal to diameter divided by 2. So in other words, the radius is going to be 24 over 2, which is just 12. And so that's what's going to go right here for r. It's 12. Again, I'm going to cross multiply, which means that 285 times 2 times pi times 12 is equal to 360 L. Okay, on the left side, when I plug that in my calculator, I'm going to get 6,840 times pi is equal to 360 L. And then when I divide both sides by 360 to solve for L, I'm going to get 19 pi, and there's my arc length. Now, as I mentioned, there is a second way you can solve this. The second way is by finding this arc length here, the one we don't want, and that's not too hard to find because it's the same idea. Degrees 75 over 360 equals L over 2 pi times 12. You cross multiply. I'm going to skip a few steps. I'm just going to tell you you'll get a final answer of 5 pi. And remember, that's the arc length I don't want. So then what you would say is you would say the circumference minus the arc length you don't want is equal to your actual answer. So the circumference, which we know is 2 pi r, so times 12, minus 5 pi, which is the arc length we did not want, that's going to be 24 pi minus 5 pi. It's going to be 19 pi, which is the same answer we got as before, which is exactly what I said would happen. And so the good news is I don't care which method you use, neither will your teacher. So you can find it using the first method, which was finding the angle we actually wanted, or you could also say find the arc length you don't want and then subtract it from the circumference. Both methods work. And then for the last problem we're going to look at today, I don't think it's actually that hard, but it's a good example nonetheless. We have a central angle right here that I'm going to call x. We're going to solve for x. I'm going to tell you the radius this time is 8, and I'm also going to tell you that the arc length from here to here, I'm going to tell you that arc length is going to be 6 pi. 6 pi is our arc length, and this time I want to find the angle. So basically what you realize is that this is just the opposite of what we have been doing. We're solving for degrees this time, divided by 360, the total degrees, equals L, the arc length, which is 6 pi, divided by 2 pi r, which we said r was 8. And again, I'm just going to cross multiply. So degrees times 2 times pi times 8, that's going to be 16 pi times the degrees. Let's call the degrees x because that's the variable I made up. And then that's equal to 6 pi times 360. And so now, what's 6 times 360? Let's see. It's going to be 2,160 times pi equals 16 pi x. And if you want to solve for x, just divide 16 pi on both sides. You'll notice that the pi's cancel, which is nice. That's why we don't have to plug in 3.14. And so we're going to get x equals 2160 divided by 16. We're going to get an angle of 135 degrees. And remember, technically that's not the central angle we just found. Technically, it's the arc length is 135 degrees. But as we said, because it's a central angle, it's exactly the same, so 135 degrees. And that doesn't matter for this problem, but there's other problems where you have to do something to that degrees. I'm talking about inscribed angles, which I'm going to cover in a separate video. But that's really it for today. Hopefully you have a much better understanding now. If you have any questions, please post in the comments below. Thank you all for watching, and I hope you have a great rest of your day. Take care, and bye-bye.